Hey guys, in this video I will go through the process of creating this scene with two mushrooms and simulation part of it, and the rendering part of it, which was done in Solaris using Karma under the stage context. The stage context itself is a very basic one. I will go through I will go through this node graph after the OBG context. And OBG context itself looks very minimal. We have two mushrooms, which basically this node is the same thing as this node, except this node is like a smaller mushroom, which you can see here. And also we have a backdrop, which I haven't used in the final render, which you might see in the stage context. So I will hide this node and I will show you just the main node. And the graph is look like this. This part is basically a kind of procedural mushroom generation. It's not 100% procedural. I will show what is not procedural exactly and what is procedural, and so basically what can be improved. And orange container is basically a simulation part. Oh, excuse me, post simulation part. This node is only is doing simulation. So I have also left nodes experiments, so you can have a look if you want to. I will just zoom at these nodes after going through these steps to show what I was trying to do. And by the way, if you're curious how I maximizing this window, I'm hovering with my mouse and clicking using shortcut Ctrl B. So yeah. So these two blue containers is separated to cap creation and trunk creation. I'm not sure how they're properly called in English. This is how I call them. So yeah, the cap starts with a simple sphere. Then I'm creating a UV texture, and this UV texture node is used to. It will be used later for the mask creation. I will show you later. And this is a settings for this UV node. And I also have left a comment here to explain why this node is used here. And I only said change to the attribute class to points here. And then I'm using a clip node like to make it look like a mushroom cap or whatever it's called. And then I'm using a poly extrude, and I was extruding outwards to create some sort of I'm not sure how it's called, I forgot. So yeah, but I guess you get the point. Sorry. And then I'm creating a mask. And if we quickly visualize this mask, actually, basically this mask is used to create a kind of rough edges, like so they're not as straight as it is right now. And basically everything that is white will be affected by this mask, and everything which is black, this will be ignored. And if you quickly visualize it, this is what it does. And if we increase the amplitude, only area which highlighted in white will be affected by this attribute noise node. And this is and this point wrangle is used using UV coordinates, which was created by this UV texture node. And if we quickly visualize it, let me switch. Oops, sorry. On the geometry spreadsheet, which was like here in the default UI, but yeah. Oops. Inspectors and geometry spreadsheet. Yeah. And as you can see here, we don't have UV textures, and here we have one. And then we're using this UV texture coordinates of the z-axis and multiplying by custom range. And in this case, range is was driven by this channel ramp. So we can create a different mask, and the effect will be different now. And then we remapping all the values to 1 and 0. This mask. And I also add this channel float value to, I guess, increase the amount, the noise amount, because if the default value will be remapped to 1, I mean, if we remapping this mask value to 1 or to 0 and 1, one value of 1 won't be enough, so I was multiplying it by 2. Not multiplying it, but changing to 2, which is a value, which is maximum value. So instead of 0 and 1, I'm changing to 0 and 2, or whatever value I put here. So it affects mask even more. I'm not sure how to explain it better, but this is how I can explain it for now. I hope it makes sense, at least a little bit, at least. So yeah, we can play around with this mask. I will change it to how it was before. And then I've created an attribute, noise. And by default, it will use a color attribute, which we don't want. We want to use a mask attribute. As you can see here. And here we can also comment it out. And the way I have visualized this mask is I clicked on the middle mouse button, Control middle mouse button, and then I clicked with Control click, or maybe Alt click, yeah, Alt or Control, and the red parts is where the most noise will be added. So, and somehow we need to pass mask value to this attribute noise. But if we do like this, we can do it like so. but as you can see, nothing has changed for some reason. So how to do it? And the way I done it is by clicking this blend checkbox and changes from constant to attribute. And here is a P attribute. Yeah, so right now it's working. And as you can see, it's affecting only mask area. So after that, after making a little bit of randomness, adding a little bit of randomness to the edges, I have polyfill the interior. So before that it was empty. After that it has end cap. And by the way, in the attribute noise I've used a zero centered noise, because otherwise it will be like not as good, I think. Yeah. So in the polyfill node, I have added an edge loop. This basically can be set to 0. And then I have also added a deform patch deform, which basically, I can simply show you. Oops. This is what it controls under the polyfill node. And then I'm subdividing the whole mesh. And after that, I will go through this process. I will go through this a little bit later. And then I'm converting it to VDB using VDB from polygons node. With this voxel size, and then I'm smoothing it out. And then I'm converting back to polygons. And this is pretty much the default values. And then I'm again transferring mask, which was created earlier here, this mask. This mask, I'm transferring it again after applying VDB. So now VDB mesh, after converting it to VDB and VDB from polygons, or I'm sorry, converting back to polygons from VDB, I'm transferring again this mask, because when VDB is created, we no longer have this mask attribute. So here we have a mask pointer attribute, and when we convert it to VDB, we lose this information. So here I'm again transferring this information, because I want to add a little bit of more variation to the edges of the mushroom. This is basically I was experimenting and trying to figure out how to do it. So this is not really necessary, I guess, but this is what I wanted to do. So here is how it could be done. And in the attribute transfer node, the left input is to geometry to transfer attributes to. So we want to transfer attributes to VDB mesh that was converted to polygons again, and we want to transfer the data from this attribute wrangle node, and then information the whole mesh with these values. And then I'm also again using this mask in the attribute noise under the blend attributes and use attributes. And here I'm only affecting the y coordinates. By the way, here I affected all of the 3 axes. So here's how it looks like before and after. Just a little bit of randomization. And then I'm deleting only those attributes. I guess, as far as I remember, I was deleting those attributes because merge node was getting a warning if I'm not doing it. So I guess it's optional. I'm not sure. So anyway, in any case, I have deleted those attributes. And then I'm recomputing normals after merging with trunk. Yeah. And I will go through this after going through the trunk process, creation process. So, what about the trunk? The trunk was created using line, a simple line, with 20 points, and the length is controlled by this controller. I will go through this controller later. And then I'm using an attribute noise, which has no effect, I guess. We'll see. And then I'm using a polywire to create mesh, actual polygons with a division count of 7. By default, it's like something like this. Oh, attribute noise is used for this. And then I'm smoothing it out a little bit, just to make the curve a little bit smoother. And then I'm subdividing this whole mesh. And then I'm adding what I call base layer noise, which has a little bit of noise applied. And then a secondary noise, which is like basically has a smaller size, element size. And that's basically what they do. And then I'm rotating the trunk 90 degrees because let's see. So because I was using a copy to points node, I forgot to explain this part. So the reason I'm using this rotation, rotating trunk 90 degrees, because otherwise it will look like this after copying to points. I also can do something like this, like unchecking this option, but this is not what I was looking for. So the reason I'm doing the transformation and copy to points is because after clipping the cap, I'm selecting the very top node, not the node, the very top point here. I'm not sure how to visualize this point. I'm not sure how to do it. But what it does is that it selects the 0 point number index which will always be this middle point. This middle point. And I have used this small vectors expression. So if the point number is exactly 0, I'm creating a group which is called top point, and I'm adding this point number to this group. Oops. And 1 means that it has been added. It will add this point to the group because, as you can see here, oops, some of the points has a value of 0, and some of them exactly 1 has a value of 1. And in vex, point groups, or groups, I guess in general, returns a value of 0 or 1, and if the value is 0, it means that the point is not located in the group, and 1 means that the point located in the group, which is exactly what we want, with what I did here. So yeah, and then I'm using this point group as a target points option. So if we preview it, it will be exactly there. And even, I will show you later that if the height of the trunk will be increased, the cap, it will stick to each other. That's what I'm trying to say. And this is speaking about this transform node and rotating 90 degrees, this is the only way I found out to make it work out. And here how it looks like. And then I'm recomputing normals, and match size is basically to place geometry into the ground plane, to the 0 ground plane. And then I'm using points to emit from. It's all over the place right now. Oh, interesting. But and what I will explain about points in a few minutes. And what I was talking about the length of the trunk is if I increase it or decrease it, the end cap will be always, they will stick to each other. And the reason is because the trunk is always copying to this single point here in the middle. This middle point. And here's what the controls looks like, just a quick controls. So it's not completely procedural as I told you. So the width of the trunk is not being affected, it's not affect the cap size, so it's not increasing as well. And I also have trunk band, which is for some reason is not located here. So this is a noise. So yeah, you can do this type of mushrooms. So the end cap, or not an end cap, the cap part is the heaviest part because it doing the VDB stuff. So this is basically an edge noise offset that has been driven by this attribute noise. And the way I did it is I created a null and click on this gearbox and edit parameter interface. And then, for example, I drag and drop some float values and then I click accept, and now you have a slider. And then I used copy parameter and go to the target node and paste relative reference. So now its node has been changed. And basically the same thing for these all other parameters. So what about the band? For some reason there is no band. But you can also add a band. Like here. And now you can capture length is the same as this one. So it, like before, it's not actually capturing the whole height of the trunk. And when I copy relative reference, it will capture it. So now, if we copy this parameter and paste it here, we now have an option to bend this trunk. But the bending will not so the cap won't be placed accordingly to the bend. So I guess this is why I haven't included the bend option here. So I will leave it like here, but with trunk bend angle to set to 0. So here we have a group node, which is basically to select points from where particles will be emitted. Right now it's all over the place because I was selecting it manually, and I selected it like so. Something like this, for example. So it only emits from, it will emit from all of those points. So this part is not completely. I mean, it's not it's not procedural at all. And to make it procedural, I would rather use a bounding box and some sort of expression to select points only in this part. I will not cover this breakdown. Yeah. And the pop network is fairly simple. Here I have the pop source. I have changed to use a source group to emit points from. By default, I guess it's something else. Yeah, it's something else as well, for sure. Yeah, so here's the difference. I have used 2 points. Geometry source is set to first context geometry, and then here I specified the group to emit points from, which is this one. And the dollar $OS is that it will use the same. It will create a group with the same name as this node. So if I call it like so, it will automatically update it. And then I'm using a pop wind with these settings. It's basically a trial and error. I'm not sure what to tell you about it. It's just you need to play around with it, I think. But these are the settings I have, and the main idea, I guess that this effect was mainly done and looks like so because of this of the bigger swirl size and lower amplitude, to give the some sort of this very gentle movement. And then I'm using pop force, which is basically used to move particles from one direction to another. As you can see, it's keyframed, and so basically from the start I'm moving particles in the negative x direction. So this is basically to simulate like a wind blowing effect. And then particles are starting moving to the positive x direction and positive z direction, and also y direction. And then they're moving again into the negative x direction and up. And I'm also controlling the swirl size to make it a little bit random. Add a little bit of randomness. And the pulse length is to make like this gentle motion effect also. So then, for example, if it will be to 1, let's see how it will be. So when it's set to 20, you have these like big chunks of whatever it is, but when you have it at 1, let's see. Oh, it's pretty much the same, but so it stays longer, like connected to each other, I would say. It's not been affected by the noise that much. So I'm treating this value as like how often noise is applied. I'm not sure. So yeah, you just have to play around with it, I guess. Not sure how to explain it better, so I'm sorry. And here I'm using a ground plane and static object, and static object is basically a collider. This mushroom collider. The better way, I think, would be to use an SDF collision, which is basically a mushroom that has been converted to VDB volume. But this is out of the context. And in the ground plane, I have I used the backdrop, this one, as a collider, as a ground plane collider. And that's basically it. After that, I'm importing the simulation using dot import node, and I'm using dot network as the spore .net, and I'm importing only a pop object because I have also set it here as well. And if I will do something like this, so as you can see, it will import everything from the simulation, but we only want to import particles. And this is why. So it will import everything that contains a name of pub object, or obj, and everything else, and everything after this after these letters. So in this case it will be pop object, and it could be like pop object, and it will still import it. So it only imports this node, which contains particles. And then I'm deleting everything except position and velocity values. And velocity has been generated by the pop network. And then I'm deleting every group. Excuse me. And here's the velocity, how it looks like. And here you can also see some stepping issues. Like here. Or even better, you can see it right here. but I didn't fix them. Then I'm deleting groups. This is basically to reduce the memory usage. So before it was using 30 megabytes, and after that it using only 5 megabytes. And this is these two nodes is used to lower the cache size. And then I'm caching the whole simulation. And I only check this in the initialize simulation OPs checkbox. And that's pretty much it of the simulation. And then I'm sharpening particles using attribute blur and setting the method to edge length. So here's how it looks like before and after. And I'm using here volume preserving and influence type to proximity. By default it's set to connectivity. And here's basically you have to play around with the sliders to get the look you want. And then I'm using this attribute wrangle to set a p-scale for karma rendering. If you're using mantra, I guess you can also do the same thing here. So then I'm setting the particle size to this value, and then I'm also applying random color just for the sake of having it. It's not really necessary, it could be like this, but I wanted to add it. And it's basically a default attribute noise, pretty much a default attribute noise values except the element size and the offset. And then I'm merging it with, I'm not sure with what. This is done for testing purpose. And then I'm outputting as a null particles. So we have a null node for particles, and we have an out for mushroom itself. And the second mushroom is pretty much the same thing as the first one. And what about this part? Here I was trying to show you. Oops. This part is basically for creating like this damage effect, not sure why. I wanted to experiment with it a little bit. So the main idea was to select random points on the cap and then group those random points and select only points that are located in the negative y direction, and to basically to select points that located near the edge of this cap. So not to select points that located on the top of the cap. And here I'm creating a sphere using a mountain node to deform it a little bit. Then I'm using copy to points. And then I'm using a boolean node to create this like damage effect. So, and I haven't used it in the final version as you saw. So yeah, this was just experiments that I had left here. Yeah, so this is for the mushroom itself. This is pretty much it. So let's go to the stage context, and it's pretty much straightforward, I would say. So here I'm importing first mushroom and first mushroom particles. which is, let me show you quickly. Here are the mushroom particles, this one, and here's the mushroom itself. Here's, so I'm referencing this null nodes, this one and this one. And here I'm importing the second mushroom, which is basically a lower, it has a lower height, and that's pretty much it. And so this is a mushroom, and this is a mushroom particles, and if we merge them, we'll get something like this. And then I'm transforming it. I basically moved it a little bit from the origin to not overlap with the first mushroom. And I have also implemented a backdrop, which I haven't used in the final render, and make me merge two mushrooms, so you'll get something like this with simulations and everything. And then I'm using a material library. This one. Oops. And you can dip inside of it. And I'm using a Material X standard surface shader. I have used these options. And I also added a subsurface scattering to each of the mushroom. And as far as I remember, I have used this Material X shader instead of Principal shader, is because with Principal shader subsurface scattering wasn't working properly. So this is why I tried this one and stick to it. So basically I have three materials for backdrop, first and second mushrooms, and that's pretty much it. There is nothing fancy about it. And then I created a camera inside Solaris camera. And I have changed the focal length from the 50, I guess, which is default. Oops. Yeah, it's 50 by default. And I guess, and yeah, and change the angle of the camera. And then I'm creating two lights. This one is an HDRI. I'm using a dome light option, and I lowered the intensity and the texture. I have downloaded from the HDRI Heaven. And to render HDRI in the Karma, so what I mean by that? So to render HDRI here on the background, you have to go to the Karma option, and under the light properties you have to enable render light geometry, because if it will be disabled, you will still also why it's like so. Interesting. Oops. This. Yeah, this is why I enable it. So for some reason it shows here also. So I have enabled this option to render it, to render the light like when making an actual render. So if we enable this checkbox, and the way I done it is I clicked on this circle and use this set grade option and enabled this option, because by default I guess it's turned off. And if we render this again, we should see the light as a HDRI in the background. Yeah, so before and after. And then I'm using an area light, which is basically like a light from the side light, or whatever it's called. And then I'm merging these two nodes and using a light mixer to control each of the lights independently without going inside each of those lights. Like going to here and changing it here, I can change it everything in here. Yeah, and then I'm adding a karma, which by default also adds this USD render ROP. And then I switched to XPU engine instead of CPU. This is a default traced samples. And under rendering and camera effects, I have enabled motion blur. By default is disabled, I guess. Oh no, I have enabled velocity blur, because by default it's no velocity blur. And the results will be quite different. Let me show you. And this velocity blur enabled. So like here you don't have any velocity blur, and here you have one. Oops. And under image output filters, I have enabled a denoiser, an Intel denoiser, and that's pretty much it. And for the rendering part, USD render ROP, I have switched to rendering specific frame range, and I have changed so it render until this frame, and then I clicked render to disk, and that's it. So hope you find it useful. Hope I was hope you get something out of it. And yeah, have a great day, have a great life. See you in the next video. All the best.